Hello juniors, hope you're doing fine today. Today we're going to see electronic assignment 25, which is solving quadratic inequalities. There's no new theory for this part, it's just solving different types of exercises. So let me show you how this works. So the only objective for today's class is to solve quadratic inequalities. So let's see, during this class we're going to see 3 different examples. And we're going to see how we can solve quadratic inequalities both using calculator and without calculator. So let's see example 36 first. We're going to solve this without using calculator. So I'm going to write here without GDC. And it says solve each inequality. And then we have part A, x squared minus 6x plus 8 is less than 0. Okay. So this is similar to what we were doing last class about the discriminant, but we're just solving the inequality for this part. So the easiest way to solve inequalities is to imagine if this was just an equality, right? Like if it was equal to 0. And you'll see that the same steps are applied. What is something that we can do here in order to solve this? Remember, solving means finding the value of x that produces the equation to become 0, right? So one thing we can do here in this case is factoring case, right? Case 5, multiply, add, and we'll find a pair of numbers that multiplied give us positive 8 and added negative 6, and those two pairs of values would be negative 4 and negative 2. So this, instead of being equal to 0, it's less than 0. So then here we need to analyze. Here's where the tricky part comes from. We cannot just say that, for example, x should be less than 4 and x should be less than 2. That's a mistake. This is wrong. We need to rather analyze what is happening. If you see this equation, this reminds you of the equation of a quadratic function in the factored form, right? That means that 4 and 2 are the roots or x-intercepts of our parabola, okay? So let me do a quick sketch of this to see what's happening here. So this is the y-axis and this is the x-axis. X and y. So if we sketch this parabola, you would see that the parabola should be open upwards, right? A happy face, because the value of a here is a positive number. And then we know the two roots, which are 4 and 2, right? So let me mark those here. Remember, we're doing a sketch only, so we can do this quickly without lots of precision. So here we have 2 and 4. So the x-intercepts are both 2 and 4. And since this is a happy face, then we can do the sketch of the parabola. Something like, maybe like this. Kind of like that, okay? So now we can analyze this expression. We want x minus 4 times x minus 2 to be less than 0. What is that less than 0 telling us? That's telling us that the value of y, which is the equation, should be negative, right? So what's the region that is fulfilling this condition over here? That region would be, let me paint that using a different color, this region over here, okay? It's the region that is less than 0, that is negative, okay? So basically my answer would be from this value of x, which is 2, to this value of x, which is 4. The one that is causing the equation to be less than 0, okay? So the answer would be that x should be greater than 2, but less than 4, okay? We're not including both because we don't have the less or equal in our equation, in our inequality, actually. So I'm not including the equal sign in the inequality. So this is the answer, okay? Is it clear? I hope this is clear enough for you. So that's you see that there's not one specific solution here. It's a range or an interval of values. We could have here a 2.5 or 3 or 3.5 or 3.75, whatever, okay? all of those values fulfill this condition, which is that the equation is less than 0. Okay, so let's do something similar with part B. Part B says 2x squared minus 5 is greater or equal than x minus 3. Okay, in order to solve this, remember we're not using calculator. So in order to solve this, we should begin by organizing this and converting it into a quadratic equation, right? So if we take all of the terms to the other side, this to the left side, this would be minus x and negative 5 plus 3, that's negative 2. Minus 2, and they should be greater or equal than 0. Okay, so now we need to solve this quadratic equation. I see that factoring becomes a trouble here because it will be case 6 and the numbers will not be pretty enough. So I'm going to apply the quadratic formula, okay? Remember the quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac, which is the discriminant, over 2a. So the value of a is 2, the value of b in this case is negative 1, and the value of c in this case is negative 2. So I'm going to apply those values into the quadratic formula, and we will get x equals minus 1 plus or minus the square root of negative 1 squared minus 4 times a, which is 2 times c, which is negative 2, over 2 times 2a. Okay, so then we need to start solving this. We would get positive 1 plus or minus the square root of 1. This would be negative 4 times 4, that's negative 16, so plus 16, remember this is square root, over 4. So then this is 1 plus or minus root 17, we're just leaving it that way, over 4. So my two solutions are x equals 1 plus root 17 over 4, and x equals 1 minus root 17 over 4. Okay, so since we're not using calculator, I need to try to make a sketch of this situation to see what's happening, okay? So let me do the sketch right here. We're gonna do something similar to the one we just did. Y and x axis, this is x, this is y. We know that this parabola should open also upwards because the value of a is positive, right? And we have the two roots, which are these two numbers. I'm not actually sure, let me think. The square root of 17, it should be 4 point something, right? Because 4 times 4 is 16. So this number, when it's positive, when it's 1 plus 4 point something, then this is a positive value, right? Positive value. But in this case, 1 minus 4 point something, that will give me a negative number. I don't know exactly how much, but this is just for the sketch. So this value over here, the first one, which is positive, would be somewhere maybe around here. I don't know, I'm just guessing, okay? So this would be 1 plus root 17 over 4. And this value over here, the second root we obtained, is a negative number. So maybe I'll write it, I don't know, over here. Once again, I'm just guessing, but it's just for the sketch. Over 4. Okay, so now that we know that the parabola opens upward and we know the two roots, we can sketch this and we will obtain something like this. Kind of something like that, okay? It doesn't matter if the sketch doesn't look quite good. So now I'm going to analyze the expression. It says that the quadratic function 2x squared minus x minus 2 should be greater or equal than 0, okay? So in which values should I observe? The equation should be greater or equal than 0 in this case. So now the values that I'll be looking at are all the values that are above above the x-axis, okay? Because they are positive. They'll be greater or equal than 0. So the region that is solution in this case would be all of this region here on this side. Remember, this continues up to infinity, and all this region over here, which also continues up to infinity. So this is positive. The intermediate region here is negative. So we're not looking at that in this case. And the last value, and the last set of values is also positive. So in this case, the solution would actually look something like this. Let me see. It would be x should be less or equal to 1 minus root 17 over 4. And at the same time, remember, we're using here union. This is something that we saw during the first classes. Union, that means and x, or x could also be greater or equal than 1 plus root 17 over 4. These are all the solutions to this quadratic inequality, okay? X could be either less or equal than 1 minus root 17 over 4, or, this is or, remember, let me write this here, or x could also be greater or equal than 1 plus root 17 over 4, okay? So I hope this is clear enough for you people. Let's go to example 37, in which we're going to use a calculator. It says, solve each inequality graphically using your GDC. Give your answers correct to 3 significant figures. So, let me show you again 2 different ways in which we can solve this now using calculator. So part A says 2x squared should be greater or equal than 7x minus 4. So the main objective here is to try to graph this function and see what condition should be applied in order to get our result. So first thing I'm going to do here is I'm going to organize this into a quadratic equation. So this would be 2x squared minus 7x plus 4 should be greater or equal than 0, okay? The next thing I'm going to do is I'm going to sketch this function in order to see what's happening. So give me a second, I'm going to show you the calculator here. So now, if you see the calculator here, we're going to go to menu graph, menu 5, and let me erase this. And I'm going to plot the function, the equation, which is 2x squared minus 7x plus 4. Remember, this should be greater or equal than 0 according to our problem. So if we draw this, you see that we get this quadratic function, and here we can analyze how can we make this function be greater or equal than 0, or what region should we look at if we want this to be greater or equal than 0. We can first of all identify the x-intercepts. Let me do that. Shift G solve and root, and we get here the first x-intercept, which is 0.72, and the second x-intercept is 2.78. Okay, so once we have those two intercepts, we know that in order for the function to be greater or equal than 0, we should pick all the values that are above those two roots, right? Because for this interval here and this interval here, the equation is greater or equal than 0. Okay, so let me go back to the electronic assignment, and I'm going to copy these two roots. So roots we found the roots using GDC, and we got that one root is x equals 0.7220, or we could write 719, we leave it like that, and the other root gave us 2.78. So the answers or the solutions to this problem are all the values above these two. Let me bring the sketch here for a second. This is the sketch. So if you see the sketch here, you'll see that this first value here is 0.719, and this value over here is 2.78. So the region that fulfills the condition, which is that it is greater or equal than 0, is this region above the roots, right? Above the first x-intercept and above the second x-intercept. So in this case, the solution would be that x, once again, we have a skip here, a jump, right? So if we write this again, positive, and for the region in the middle, this is the equation is the quadratic equation is negative, right? I'm gonna put that a little bit down. Oh. Just to avoid confusion there. Okay, so the region or the solution would be a jump once again. Its x should be greater or smaller or equal than 0.719, and at the same time union x should be greater or equal than 2.78. This would be my solutions. Okay, I hope this is clear enough. Now let's see part B, which says that 3x squared minus 7x should be less than 2x minus 2. Okay, so another way of solving this is by doing the following. Instead of, if you want, you can organize this into a quadratic equation, but if you want, you can also leave it just as it is, okay? So we're gonna plot two functions. This first one, which is a quadratic function, and this second one, which is a linear function. So remember the sign. It's the quadratic function is less than the linear function, okay? So if we go back to the calculator now, let me go back to the problem, to the graph. This is my new graph. I'm going to erase this, and I'm going to write first the quadratic formula, quadratic equation, which is, 3x squared minus 7x. And the second equation is a linear function, which is 2x minus 2. If we plot this, let's draw this and see what happens. We get a quadratic function, the first one, and a linear function, the red one over there. So we want to see, the condition was that the quadratic formula should be less than the linear function. So where do you guess that is occurring? If you take a look at here, from this intersection point to this intersection point, the red line is above the blue line. So for that interval of values from this intersection point to this intersection point, the linear graph is above or is greater than the quadratic function. So let's calculate those two intersection points. Shift G solve, intersect, right? F5. And we get the first point over here at 0.242, and the second intersection point is at 2.76. Okay, so those will be my interval, or the limits of my intervals. So if we go back to the electronic assignment now, you would see that, let me write those two values. So using GDC, so let me write the steps here. Yes, using GDC, the first thing we do is graph both functions. And the second thing we do is we calculate of find intersection points. So the intersection points are, first of all, x equals, I'm only writing the x value, 0.242, and the other x intersection, x coordinate of the intersection point is 2.76. Okay, so this is how the graph looks like. Let me bring this up here. Let's do this a little bit bigger. Okay, so you see that the first intersection point occurs here at, this is, if we take the x value, this is 0.242. And the second intersection point, oh, this is there's a mistake here in the graph, actually. This is not correct, but this should actually be 2.76, although it doesn't look like that in the graph. Remember, this is just a sketch. So the interval where the green line is above the parabola, the purple line, is for this region. Let me do that with orange. For this region here, right? For all this region, the green line is above the purple line. So the answer would be from this intersection point to this intersection point. Okay? So if we write that using interval notation, we would write here 0.242x, should be less or equal, no, only less, because we're not contemplating the equal sign. So it should be less than x, and this should be less than 2.76. This will be the answer for this particular exercise. Okay? So this is another way of solving inequalities, by graphing both functions instead of reorganizing the equation into a quadratic equation, into a quadratic inequality, actually. Okay, so I hope this is clear enough for you people. Let's go to the last example, example 38. It says, find the value or values of k for which the graph y equals x squared plus kx plus 9 has no x-intercepts. You already know how to solve this. Let's try doing this without a calculator. So, first thing we were given as data is that we want this quadratic equation to have no x-intercept. In order to have no x-intercept, remember the condition is that it should not have any real roots. So the discriminant in this case should be less than 0. So that's where we're gonna start solving this. So let me write the equation here. Y equals x squared plus kx plus 9. So we can identify the value of a, which is 1, b is k, and c is positive 9. Okay, so remember, the equation of the discriminant is b squared minus 4ac, the inner part of the radical of the quadratic equation. So if we want to this condition, discriminant should be less than 0. We're going to write b squared minus 4ac should be less than 0. Okay, and I'm going to fill in the data. K squared minus 4 times 1 times 9 should be less than 0. And now I need to solve this. K squared minus 36 should be less than 0. So finally, we could either take this to the other side and do a square root, or we can apply here a difference of 2 squares. Let me do that. That'll be k minus 6 times k plus 6, right? Difference of 2 squares, this should be less than 0. So if we do it this way, we're going to see that this is written in the factored form, right? Where we have the two, let's say, the roots of the quadratic equation. So if we do a quick sketch of this to see what's happening, we're going to have something like this. This is x, this is y. We have both roots, which are positive 6 and negative 6. So 6 over here and negative 6 over here. We have the two roots. And we know that this parabola should open upward, right? Because the value in front of a, what is supposed to be our a, is positive, right? So if we do the sketch here, the parabola would look something like this, okay? So what do we want? We want this product to be less than 0, okay? Less than 0 means that we should be below the x-axis, okay? So our solution region in this case would be this area over here, right? The area that makes the parabola be less than 0, okay? That's below the x-axis. So finally, our solution to this problem would be that k should be between -6 smaller than k smaller than 6. I'm not including the equal sign because we don't have the equal sign up here. So this is our solution. The values of k are any value of k which is between -6 and +6. And I think that was, yes, find the values of k. So that's it, people, for today's class. I hope this was clear enough for you. If not, please let me know any doubts you may have through Google Classroom or WhatsApp or however you want. So I hope you have a nice extended weekend, and see you Monday.